Thank you for coming back in. I'll now hand to Professor Alan Rowan, who is the Director of the Australian Institute of Bioengineering and Nanotechnology.
Well, thank you, Emma.
Thank you very much, Alan.
It's great to see such a good audience here and actually an amazing panel of experts. And I actually just flew in last night from Germany, where we signed an agreement between the Queensland government and the Fraunhofer Institute for the development of flow cell batteries. And it was interesting in Germany where they said, you know, we have this major problem that we have a real energy crisis. We've lost gas because of what's happening in the Ukraine. We have all of this energy being generated in the north of Germany, how to get to the southern Germany, and they're in a real crisis of energy where batteries are going to be actually essential for driving everything, and we can talk about that later. Today we've got a whole panel on battery manufacturing, and we've got a whole panel of experts, and I just wanted to systematically first get them to come up to introduce themselves, talk about a little bit about the science they do, and then we'll jump into the question of where do they see the opportunities, where are the gaps missing to actually enable us to transition to the real implementation of these batteries in society as soon as possible. Jenny? You're first. I shall let you jump in first because we'll just go down this road.
Thank you. I tried not to sit first and then they all moved. So I've ended up first. So I'm Professor Jenny Pringle. I work at Deakin University. I'm the director of an industrial transformation training centre, Store Energy, which is designed to facilitate the training between the academia and the industry. So we have industry partners like Calyx, and just to make sure that the PhD graduates that we're graduating do that with the skills that the industry really need. And it's sort of one of the things that I think will hopefully come out of this is the importance of training. That was one of the things I wanted to touch on. So our wider group, so myself, Professor Patrick Hylett, and Professor Maria Forsyth, and we're quite unusual in the research that we do, which is everything from the molecular modelling, which is really important, through the new materials design and synthesis, and my particular areas in the electrolytes, particularly anic liquids, plastic crystals, polymer electrolytes. Solid electrolytes have already been mentioned a few times today, which is great. And we go right the way through to the device assembly, so particularly lithium metal batteries, sodium batteries, and then we go right the way through to the pouch cell. We have a battery prototyping testing facility at Deakin that can make pouch cells using new materials, for example, from our industry partners, anic liquids, and so forth. So I think that's enough in the introduction.
Fantastic, Jenny. Thank you very much. This works here. I think you could now introduce yourself now because you're already there.
Yeah, I might as well. Hi, I'm Niraj Sharma from the University of New South Wales, and I work on basically materials development, often ceramics, to do with essentially anything in the battery space, so from electrodes, solid-state electrolytes, looking at making coin cells, so we can go from ore to coin cells. We're looking at a bit of recycling, and a lot of things we're doing at the moment is targeted around advanced characterization, really understanding the chemistry of batteries, and I'm a chemist, so it's very close to my heart. Thank you very much.
Thank you very much. Please. You seem to have missed the slide.
Good morning, good afternoon everyone. Adam Best, I'm from the CSIRO Manufacturing and I'm the co-lead of the Renewable Energy Powerhouse Mission in Development. CSIRO is currently reorganising some of its research activities to around what we call a challenge strategy. And one of those two of those challenges that we're trying to respond to is the challenge of the sustainable environment and resources that we look at, and also future industries. And within that, the Renewable Energy Powerhouse Mission and Development is about how we bring a holistic response to R&D in the challenge of producing renewable energy for the future in Australia. We are currently looking at how do we actually deliver more value from our critical minerals towards our energy system. So how do we look at that full value chain from minerals in the ground, processed, battery active materials, cell manufacture, to systems in order that we can actually address some of the energy challenges we face in the nation. And key to that piece of work is how we actually work in a bigger picture of not just individual projects, but how we work with government, industry, and the innovation sector to be more holistic around some of the social challenges, mining, developing new industries, because without this more holistic approach, we will be unable to take advantage of some of the opportunities that are in front of us. Thank you.
Speaker, would you like to jump up here? Thank you. I think you have a slide, don't you?
Yeah, I have a slide. I'm not sure if you want to put it. My slide. maybe not that one? Oh, yeah, I don't know. It's probably the last one. This is important. There we go. That looks good. Okay, hi everyone. It's nice to be here. My name is James Vaughan. I'm here from the University of Queensland. I'm academic in metallurgy and specifically hydrometallurgy. I'll just say a few points, maybe summarizing some of the things discussed today. So Australia is obviously a major producer of metal commodities, and there's a growth in the area, especially related to batteries, material supply chain. So there's scope for expansion and even new refining technologies to come into Australia. Decisions about process technologies depend heavily on what the final product you're trying to make is, and therefore it's really important to have battery manufacturers who are pulling for specific materials to be working with companies that are actually extracting and processing the materials that go into those manufactured products. Okay, so local refining and battery materials production will be bolstered by the need to recycle. For example, I think there is good recycling programs for lead-acid batteries here. It's a little bit unclear to me anyways what's happening with the lithium-ion batteries, but in terms of hydrometallurgy, that's been one of the major hot topics globally. There's many opportunities for process innovation here, which can give competitive advantage from my point of view. Myself and Professor Lianzi Wang and Lynette are working on putting a bid in for a training center in metal and materials kind of supply chains, which would help solve a piece of the puzzle for battery manufacturers. So if anyone wants to discuss that, then we're happy to have a chat. Thanks.
Good afternoon, everyone. My name is Lianzi Wang, and a group leader in ARB and also Australia Laureate Fellow in School for Chemical Engineering. It's not me. Sorry, another one. Before I, going to my science, I wish to take this opportunity to thank one particular person. But 2 years ago, and we organized something, a small-sized meeting. I think Adam was here, yeah? So in that, in another smaller room, about 10 people were there talking about the battery idea. And then last year, this time, we have about 150, around 200 people attending in our chemical engineering building. And this year, you see the cohort. And so without the great support and from many people like Queensland government and the university and all the participants, we couldn't do this. But most importantly, we need to thank Lynette. And I think you are really the driving force and to make this thing happen. Thank you very much, Lynette. So now it's going to my research. I'm trained as a material scientist, and so I started to work to make battery cells back to 2001 when I was a fresh postdoc in Japan. At that time, I think the battery sector is very different from now. I work on lithium, cobalt, and lithium manganese. After 20 years, more than 20 years time, I think we see these areas now growing so dynamically. And so I was very lucky actually to have a number of local industry partners working with us. Like we have a number of industry partners sitting in this room, like Redflow and energy storage industry. So Asia Pacific, both of the company working on Redflow and on flow battery, and with Dr. Bin Luo. And we also have Lithium Australia and a very small particle company working on LFP and MFP. And we also have the peer battery technology, and they all based in Queensland, in Brisbane, working on AMBC. And so, but if you already heard a lot of wonderful talk this morning, and talking about the great opportunity, but still actually there are a lot of gaps in between, like from the research and to the industry commercialization. And this is the reason why we are here. And the government people and the industry and the academia, and we work together actually to achieve, the big target actually we are dreaming for. Thank you very much.
I hope so. There it is. Yeah, here you go. Hey, how you going, everybody? For those of you who don't know me, I'm Dr. Joshua Watts. I'm the director of the Energy Storage Research Group at QUT. How do I go to the next slide? Oh, yeah, that makes sense. Just quickly, and this has already been touched on so many times today, but I mean, the opportunity for Australia and Queensland to value add at the moment is just massive. Right? We've got all the critical minerals. There's just so much value to be had, especially if we move in the right direction, in the right ways, especially in relation to some of these big steamrolling things like the IRA and things that are happening, and setting up partnerships there and doing similar things. So we really do have the capabilities here to move downstream and start value adding, especially in that front end area, and then towards adoption and integration. And Queensland especially just has an amazing battery cluster at the moment. It's just sort of organically grown, and we have this amazing network here that we can go through and leverage that and do some really amazing things. So at QT, we have the Advanced Battery Facility, which was a facility that was established in 2014 as part of the Automotive Australia CRC. And it's basically a vertically integrated value chain for batteries, a pilot scale. So we can start from the very start of the process. We can take the raw chemical inputs, whether it's for nickel, manganese, cobalt batteries. We can take the sulfates, the lithium hydroxide. We can actually make the precursor products, add the lithium, go through, test those, qualify those. And that's a really important part of the puzzle as well. Through the whole stage of the value chain, you've got to be able to test and qualify the components as you go through. The battery development cycle in general is a very long and arduous process. You know, it's 10 to 20 years from a lab scale breakthrough to something that you can actually put into a product. And it's just the nature of batteries themselves. They take a long time to prove out, and they're quite difficult to scale. So we have that at pilot scale at QUT, where we can take those materials, do that. We can also then build the cells themselves, whether it's the coin cells that you use to do the qualification. We can do the pouch cells, multi-layer pouch cells, cylindrical cells here as well. And then we've also developed a battery testing microgrid, so we can do the large-scale testing. And that's a really important piece of the puzzle as well, is the integration part, the demonstrating consumer confidence in the technologies. There's so many batteries needed at the moment, and we just don't have enough. And so we need to diversify and make sure that we're using batteries in the right way across the whole ecosystem. Especially for the large-scale systems that we need for renewables integration, nobody's going to buy them unless they see one working. And so for these non-lithium technologies that aren't really proven out yet, you need to test them on the ground and do that. And we've already done that nationally, working with ESI specific for the iron flow battery. We deployed and tested that over the last 2 years, started in January, and that's a big reason why they're starting to get some traction and adoption here, and setting up amazing collaborations nationally as well to develop the system. So we also do other systems like NAS batteries, which are another system that doesn't get talked about that's really good for large-scale energy storage. We're also do a lot of training, and we're working with state, federal government to work on upskilling of people as well, to make sure that we can get the skilled workforce in place, because that's not really talked about as much as a bottleneck. We talk about a critical minerals bottleneck as we go through to manufacturing. We've got a skill set bottleneck too, and we need to make sure that we're upskilling people for the jobs that we need. We've been fortunate enough to get some future battery CRC grants in place, and this is 2 of those. I won't go into too much detail, but again, supporting that scale up of the vertically integrated battery value chain to test the materials, get them into systems, do the certification as well. So actually get the products to market is another piece of the puzzle. We do that whole battery scale-up process, so we can take customer materials, we can put them into coin cells, do the single-layer pouch cells and the multi-layer pouch cells, and then into whatever the final use format is, do all that work, that prove-out work that's required to actually get a functioning system in place. And as part of that, there's very bespoke testing infrastructure that you need, that we're building capability to support there as well. I mentioned the battery grid, where we can do all the large-scale testing stuff. This is currently being expanded as well, and we can be able to test multiple systems in real-world scenarios with the renewables integrated as well, to go through and do the control systems methodologies. Also looking at hybriding of systems. You know, different battery technologies have different sweet spots where they operate, and the answer isn't one battery. It's multiple batteries working together harmoniously in the sweet spots that they operate in. Very active in lithium battery standards and safety as well. So we're gearing up to do destructive testing with Queensland Fire Emergency Services at their White Island facility, where we can take large systems and cells and put them into destructive testing scenarios, which is just, it's critical. Everybody needs that capability and we don't have it on shore yet, so we're developing that as well. And I'll finish up with amazing support we've had from the Queensland State Government recently with the establishment of the Queensland Energy Storage Technology Hub, Crest Hub, where they've put in $15 million to work with us, the other universities and local industry partners to build that value chain. So start value adding to our critical minerals to make the components that we need to make the batteries, and then supporting a wide range of other activities as well, flow batteries, systems qualification, again, more lithium battery stuff, but also looking at the critical components that you need to make cells, like membranes, anodes, cathodes, that kind of stuff. Thank you. Cheers.
Professor Watford here from the University.
Good afternoon, ladies and gentlemen. My name is Guoxu Wang. I'm the Director of Center for Clean Energy Technology at UTS. So at UTS, my team mainly work on the research and the development of different battery systems, including lithium-ion battery, lithium-sulfur battery, introduced this morning by lithium-sulfur energy, and lithium-air battery, zinc-ion battery, and sodium-ion battery. Today, I would like to take a liberty to talk about the two critical items in the battery ecosystem. One is the battery safety. So you can see there's frequent reports of the EV accidents worldwide, globally. Doesn't matter in the hot weather or in the cold weather condition. And back to Australia, this is just two weeks ago at Sydney Airport. One luxury EV, Lexus, caught fire and then damaged, destroyed 5 labeling cars and then damaged additional 20 cars. And then AMBC journalists called UTS media, ask whether you have some battery expert to explain this phenomenon. I think with the wide range adoption of EV, this kind of accidents will happen again and again. And then for, this is a large stationary battery near Geelong in 2021, when the commissioned this battery storage station fire. There's a big fire. If you click the video, you can see, yes, there is a sound, there is a voice. You can hear it. There is a firefighter talk about this fire, how to put out this fire. It's very, very difficult.
The plan is that we'll let the battery bank burn itself out. Now it's about 15 metres long by 3 metres high by 3 metres wide. There's another one right beside it that is currently burning as well. So we cannot put them out with water or anything else. The best way to deal with these things is to let them burn until they are burnt out. If we try and cool them down, it just prolongs the process. So by letting them burn, and this wind's helping us by keeping it burning fairly freely, but we could be here anywhere from 8 to 24 hours whilst we wait for it to burn down. Look, we're not that concerned because it is a fairly isolated location where these batteries are, but you know, we put that out to the community just to make sure that they are aware that there is a fire in the area and just to be cautious. That's really all it's about.
Okay. So you can hear the firefighter talk about it's difficult to put out this fire. Just let it burn by itself. So recently in my lab, we developed a non-flammable battery chemistry, which is we call it the non-flammable quasi-solid state gel polymer electrolyte. So this video, you clearly see, so for conventional liquid electrolyte, easy to burn, to make fire. But for our newly developed solid state electrolyte, it's non-flammable. Even you use a fire to ignite it, it cannot be generate a flame, cannot be ignited at all. So it's absolutely safe. We really want to commercialize this technology. We published this paper, but most importantly, we want to commercialize this kind of technology, advanced battery technology in Australia. And then I would now like to highlight the battery recycling with, like Joshua talked about, more and more battery will be in the market. And then more and more batteries need to be recycled so that we can save our resource and then to make a circular economy for the battery ecosystem. So we developed this technology. We can very efficiently extract the lithium from different cathode materials. The cathode materials, the lithium iron phosphate or lithium nickel cobalt manganese oxide. We can extract the lithium from spent battery cathodes, and also simultaneously we can generate hydrogen as a byproduct. So this is also very exciting technology. We would like to seek commercialization in Australia. So this technology can recycle almost 100% recycle lithium extracted from spent batteries, and the product is lithium hydroxide. And simultaneously, we can generate hydrogen. Thank you for your attention.
Well, what an amazing bunch of scientific academics. Amazing science. No, I didn't mean that in a sarcastic way, to be honest. But it is interesting, and I'll go through all of you individually in the panel, but we have serious problems to solve very soon. And given that in Queensland we've set that the net zero will be 2035, which is a scary number because that's only 11 years away, 11 and 12 years away. How are we going to do this? So Jenny, I mean, what would you say in the next 3 to 5 years you could do from your science, which you think you can start to get towards trying to implement, and how would you do that? It's not an easy question, but there's a certain urgency to what we have to do, so it's not just academic anymore.
Yeah, that's right. I'd like to touch on a couple of things. So first of all, in terms of safety, because for example, lithium metal batteries, well, every technology has its pros and cons, and so we've got to realize, and sometimes you see in the media when there's a battery advancement that they promote it like this will solve everything. We all know lots of different technologies for lots of different applications and so forth. Some of them will be suitable for grid storage. Some of them will be better for individual stationary backing up solar cells, for example. Lithium metal batteries, I think, are super promising for the high energy density electric vehicles. There, the challenge for flammability is even worse. I mean, lithium metal is extremely reactive, as is sodium metal that we're also developing. You
might have just noticed that cargo full of cars, yes. 3,000 cars caught fire just off Germany.
Yeah.
That's the second one, by the way, to go down with 3,000 BMWs.
So we need to address that flammability. So anic liquids, other sort of modified electrolytes, super important. In terms of, I also want to touch on, as we're developing new electrolytes, so people have mentioned recycling, because there's this huge tsunami of used lithium-ion batteries that are going to be piling up, in 10 years that we still don't have really viable, economically viable ways to recycle. But we've got to be considering how we address that for the new technologies. The more different types of battery technologies that we have, and especially even the different styles in terms of cylindrical and so forth, the more challenging recycling is, because at the moment they all end up in one big collection heap, right? So we've got to be considering how we're going to recycle those now, and now is our chance in terms of the next technologies, how are we going to design for recycling? How are we going to incorporate some recycled content? How are we going to get away from things like fluorine that are already being, outlawed in various places, so that we don't have that problem for the new technologies in 10 years' time? So that's a very long-winded answer, but those are some of the things I think that we are really important to be considering.
Well, I'm going to put you on 3 years, which is the first thing that you're doing, which you think will be biggest importance to translation next 3 years.
Lithium metal batteries, safe lithium metal batteries for high energy density. That's where I'm at.
On the spot. Perfect. Thank you very much. Professor Sharma, what do you think? Where do you see the opportunity? Next 3 to 5 years, what you're doing, we can really make a difference.
If I can just do the safety thing, just
No.
briefly. Can you put up my slide, please? It's just one of the next ones. So we've recently bought an EV and a solar and a battery system at our place, and I'd just like to show you the labels we have on our battery system. It'll come up in a minute, but that's fine. So while that's happening, and you can just sort of see essentially the scale of, or how conscious people are. But with a little blue logo with an EV on there, is that sufficient for the fire brigade to say, well, this is how do I deal with it, right? So that's the battery we've bought, right? Can you see all the labels? That's a bit overkill, right? Whereas the car has just an EV little triangle on the number plate, right? So labeling is important. But to answer your question, 3 to 5 years, I think actually translating is quite tricky. And actually getting that there's this whole divide on how do you translate quickly, and are we translating quickly and at a risk of not getting the best material out there? That's important. If I was going to say what I'm interested in and what I think will be quite interesting, it'll be interesting to see what sodium-ion batteries do at the moment. I've just ordered 30 from a supplier in China, just to see what they're like. But I'm interested to see whether that will displace some of the lithium technology in energy storage.
Yeah, thank you. James? Oh, sorry, no, sorry. Sorry.
Not James. Thank you. So actually, my colleagues and I have been spending quite a lot of time on this question, thinking about what we should be doing now and urgently, just so we're all clear. If Australia does not move in the next 3 or 4 months, the train's left the station. Companies are investing money and capital in plants and manufacturing facilities. And once they've established that, they will not be moving. So Australia has to move now. This is no longer a research question. This is now about what can we build now that uses the resources and skills that we have in this country. As part of the Renewable Energy Powerhouse, we talk about, well, where do we work in the battery value chain? And we talk about midstream manufacturing. So is that cell manufacturing or is that active material manufacturing, so battery active materials? And we've landed on, we believe it's battery active materials. Why? We have a competitive advantage in critical minerals. They're on our doorstep. We have them all in the ground. We have the know-how, we have the skills, we have the world's leading mining in order to actually recover those minerals. And James has pointed out very eloquently the challenges that go with that, even if it is on Tatooine. But we have to build plants like what Stephen Grocot's talking about, such that we can actually take advantage of our competitive advantage. If we don't, we moose the bus. We have to do it now. So this is graphite, nickel, cobalt, manganese, all the critical lithium, all the critical elements that make NMC, LFP, spheronized natural graphite, and if you want to go further into HPA for separators, and if we can build the capability, copper foil, aluminium foil. All of these are part of the global battery supply chain, and we can have a very strong play there. Once you have that, then it's a very short step to cell manufacture. I'm not saying it's easy. I've been on that journey with Energy Renaissance, and it's a bloody tough exercise. But just so we're clear, no one in Australia can make a lithium-ion battery yet, and that's something we need to do in the next 3 years. Because if we can't, well, it's okay to be in a lab, right? But you've got to do it at volume, gigawatt hours. Otherwise, we're not solving a problem. So if I'm doing anything, I'm building Australia's first BAM plants as quick as I can.
Thank you. I mean, this is a really important point you make, is that we don't have the time we think we have the time.
No, I don't.
And this was something from the meeting in Germany, which was really, we have to do something tomorrow. where they're saying, and that Australia is a really good test bed for this, because all the minerals are there. We have energy, as it were, renewable energy to store, which we want to convert to a variety of different things. So how do we, I think you're right, we have to choose a technology.
Yeah, and to be honest,
which one would you choose?
I'd choose lithium-ion because there's a global battery supply chain that you can contribute to.
Yes.
But that's not stopping us from making anything for sodium-ion batteries either, because some of the higher capacity sodium-ion layer cathode materials, they require nickel, manganese, iron. We have to play to our strengths. We can't go and fight in the weeds with others who have more experience doing this cheaper, fast, or whatever. We need to work to our strengths, and if we don't, we only consign ourselves to lose. We have to play on the field we're the best at playing on.
So I think that's right, because I think I was talking to Craig from GMG, and he said, listen, a lithium battery plant or a sodium battery plant or an aluminium, two-thirds of it is exactly the same for each one. We've got the graphene, we've got all the other bits. So that would be the thing you'd tell to the Queensland government, do this now.
I would say
any government.
Give to anyone who wants to build a BAM plant what they need to do, because you're playing to your strengths. All you're doing is moving 1 or 2 steps down the value chain. Yeah. You're building on existing skills and capability. And we are writing a report on this, and we will release a report. We just have to be a bit mindful when we release it. Yeah. But it does talk about the opportunity and where we can play. And just one last point, recycling plays a big role in this, because the circular economy is key.
Yes.
Because you can only make recycling work where you have midstream manufacturing. Otherwise, all you're doing is recycling something and you're going to send it to China again.
Exactly.
So you need the midstream manufacturing for recycling to work. That's really critical. That is the gap.
Appreciate that. Perfect, Adam. Thank you. Now, James, it's your turn.
Okay, thanks, yeah. So I guess from my point of view, what we're doing right now is raising awareness about the issues to the undergraduate cohort who have gone through. So we rebranded our second year course, Introduction. It's called Metal Production and Recycling. We have about 30% recycling content, and we tell these stories. So we have next week we're doing e-waste and lithium-ion battery recycling kind of workshop with the second year students. We also need to get the numbers up of those types of students coming through. But I do think they latch on and get excited about this particular topic. In fourth year, we've 3 years in a row now for the School of Chemical Engineering, we've had lithium-ion battery recycling design projects, so 100 to 120 students per year have reviewed and designed battery recycling plants coming from UQ, so that's 300 or 400 students coming out with that kind of experience. In terms of research and development, we do have there's the Critical Minerals Trailblazer grant, which is operational now. The whole mantra for that project is to find companies who are trying to put in new technology and facilitate them going up the TRL, something that's already established, not new technology, but something that's already at 5 to get it to 6, 7, 8 and get it implemented. So that's happening now, and there's opportunities for companies to engage with that project.
That's very important, yeah. Yeah,
I cannot agree more with the point Adam made. So if you look at the battery market at this stage, I think certainly in the near term, next 3 to 5 years, even 10 years time, no other product can replace lithium. So that's a reality. So in the near term, I think we are lucky to have, all the resource and also a number of companies working in this space. Actually, if we are working hard and working efficiently, certainly we can go to the market immediately. So like the AMBC lithium, lithium ion phosphate, and also the graphite work. And also some other part of the energy storage sector, like the flow battery for the stationary storage. I think that will also play a role in the near term. But in the longer term, and because we are working in the research institute, we also need to position ourselves for next generation, battery like aluminum ion, sodium, and solid state, and even the lithium sulfur. And so in the, maybe say, 10 years, 20 years time, I think, so the lower cost, I would say, maybe high energy density battery will have a significant role in play. And we also need to position ourselves actually towards that area.
Completely agree, Leon and Jules. And I'll reiterate a support of your points. It's really important that we capture the opportunity now and value add to our critical minerals and strategically identify how far downstream we go. If we do go all the way downstream, we've really got to make sure that we have local offtake for that and set those up, because you need to make sure that there's adoption in place to secure that. But in international export markets at the moment, there's a huge need for all of these materials, you know, cathodes, anodes. But one thing that we can do, and we have an opportunity to do, working with all of these amazing researchers, is innovate in that process, not just carbon copy what everyone's doing, actually add further value to these products by making them better, making them safer, increasing their capacity, working with solid state electrolytes, all these kinds of things where we can actually improve the products, and that gives us international competitive advantage as well. A lot of these things have razor thin profit margins, so they're very hard to compete with. So if you're going to do it, you've got to make sure that you do have a cost competitive product. That's where you've really got to be careful where you move downstream, that you're not going to get steamrolled by some of this crazy stuff that's happening overseas. Like, you know, the IRA is just it's a beast, and it's already creating billions of dollars of economic value for America. There's going to be a bit of a brain drain happening there with all of the expanding businesses over there. I was just at a conference, gave a presentation on Sunday at the Masters Electricians Australia conference, and there was a guy there giving a really good summary of what was happening in the States in regards to the IRA, and he's saying that businesses over there are having to 5 to 10x their employment just to keep up with demand of electrification. And so that's going into homes and things like that, batteries, solar installations, electric heaters. You know, that's a big place where we can work at on the ground right now is electrification of households, but there's also the large-scale grid integration of renewables that we need to do. For mobile applications, for where you need high power to weight, you've got lithium. For other applications, static energy storage, there are other options out there that need to be explored and looked at. Yeah. And the solution is going to be a diverse range of energy storage. It's not just going to be lithium. And so when people ask what's going to win the race, there is no one technology that's going to win the race. We need it all. There's not enough minerals or skilled workforce at the moment to meet the demand we have for lithium batteries at the moment. And so those production capacities are going to be curtailed down, and things like sodium ion will step in and fill those gaps, because that is actually becoming commercially mature quite quickly, because it's very similar to lithium batteries. You make them in the exact same way. So we need to work in understanding what works here, locally. What do we need? What works best for our use cases, and lean into that. Work downstream in manufacturing those products, but then also really look at where we can compete internationally and provide export commodities and value-adding short downstream opportunities, like, you know, making the cathode the anode active material, because there's a huge global demand. I've just been around the world talking to a few people about this, and one of the biggest risks that some of the manufacturers have overseas is a stable supply of cathode, right? Because they're worried about it. It's really important to be able for them to make batteries. So there's a real opportunity for us to be strategic in how we value add and innovate while we're doing it.
Fascinating, because so what you're sort of saying is that you see an opportunity for Australia really being this commodity, so the cathodes, the electrolytes, the graphene. We can be doing that. At the same time, we've got this cutting-edge technologies, but we also need to be having, as it were, proof manufacturing facilities, because there's always that cyclic development to enable us to get to a point where we have a potential manufacturable product, and it will be built in different places in the world because our costs are very, very high. Is that what you're sort of saying?
Yeah, for sure. But there's certain things that we can't potentially do yet, and you know, people need batteries right now, and we haven't moved quick enough to be able to manufacture the batteries, and for lots of different reasons. But batteries expire. There's going to be another round of demand of lithium batteries, yes. And so we need to mobilise and get ready to enable the supply chain so we can manufacture those and we can sell into the second wave of batteries that are required and manufacture those products. Yeah, like there's a technology out there called NAS batteries. It's liquid metal sodium sulfur. Been commercially mature for 20 years. Yeah. And they work. They're really good for large-scale, long-duration energy storage applications. Perfect for grid integration.
The large vanadium flow cell batteries, Shimamoto, have been around for 10 years, and it was just technology ahead of its time, which could be implemented tomorrow. Yes.
Yeah. So really got to look at what we need here and where we can fit in globally.
Yeah. Brilliant. Professor, thank you. Please, you're the last.
I totally agree all panel members' opinion. So, and I also agree our Prime Minister's claim. Australia will become superpower of renewable energy. If you consider we are resource country, we have all elements, lithium, nickel, cobalt, copper, aluminum. We can make to become play a very important role in the global battery supply chain. Not only just minerals, we also need to establish a refining industry, like in Perth. They established the lithium mineral processing facility, like TNG, IGO lithium, process lithium minerals to lithium hydroxide. That is a value-added process. That's both job opportunity and boost our economy. And I remember when about 10 years ago, we had our automotive CRC. At that time, the Australian federal government did not provide subsidy for auto industry. So the three major car company moved out, Ford, Toyota, and Holden, all gone. At that time, we, as auto CRC, we need to have industry support. So we couldn't get industry support from our local industry. Eventually, we got support from Malaysian government. So I think with now the auto industry is experiencing the revolution, move to EV without a doubt. So the petrol-powered car will be phased out gradually within 10 or 20 years. So this provides an opportunity for Australian industry maybe restart our car industry in the future. That's many people from our previous colleagues in the auto CRC, they hold similar opinion. So maybe there is opportunity we can restart EV industry in Australia. Currently, like in Victoria, some company modify petrol engine to battery-powered light truck. This is a smaller part. I think if we build up very strong battery manufacturing in different states, not only in Queensland state spearhead the battery manufacturing, I think other state government should follow the Queensland government, put more investment, more initiative in battery materials, battery manufacturing industry. And also, I think the federal government policy is very important to boost business, to build confidence for business to invest in the battery industry.
Well, it is very interesting that all the big lithium batteries are not in Australia, the big factories being built where the cars are manufactured. So maybe we need to build the big sodium battery.
I think Adam talked about the volume. You need to gigawatt, tens gigawatt, or even 100 gigawatt capacity. That's the important. Yeah.
So we are limited with time, but we also wanted to put this out to the audience. You've got this expert panel here who are doing the current and future science, all working with industry. Does anybody else out there have a question for them to pick their brains? Please, let me give you a microphone here.
Paul Beckett from Bosch, Australia. So it's not really a question, it's more of a statement and more to what Josh was saying there. Time to market, time to production, basically saying need to be making decisions now. From an equipment manufacturing point of view, we provide production line equipment and production line solutions. And our lead times in the last 3 years have gone from 12 months to 18 months to now 2 years. So, anyone engaging us on a complicated production line or a factory, we're now quoting a lead time of 2 years. Now, talking to a player in the market based in New York 3 years ago, he was saying it'd be excellent if BAMS can get involved in producing equipment for this space, because lead time 3 years ago was 2 years for cell manufacturing. So presumably capacity in the world has increased. So really the statement is that there's a tension and a pressure to get into manufacturing quickly, but where do you get your equipment from? That has to be factored into the equation. And for me, it's around planning and planning early. What do you need? When do you need it? And when do you need to be producing in volume?
Yeah, and I'd add to that as well that same to that innovation comment is we have an opportunity to actually start making the equipment here as well, and actually innovating how you make batteries as well. I mean, that's a tough nut to crack, but solid state batteries, for instance, the way that you make those, especially the solid ceramic type solid states, you have to change the way you make the battery. So you're going to have to change the equipment. And so there's an opportunity for us to do that, actually make the equipment that makes the batteries, the systems as well. Automation is key to the whole thing. You have to be able to automate Industry 4.0 the whole way through as much as you possibly can. It's necessary. You can't not do it to make it cost competitive.
So you're suggesting that we need some sort of national prototype battery manufacturing facility for the whole of Australia?
Yeah, that could be very helpful, but again, you've got to be careful how you do it because you can't compete with industry. So if you're supporting industry, you can't be the manufacturer. You've got to do it in a way that you're actually providing service.
But I mean, we have all of these different NCRISs, which are infrastructures paid for by the government to support the driving of industry. Something along that direction, which is about upscaling and manufacturing batteries.
Yeah, absolutely, and that's what we do already with ABF and CRC projects, and the Australian Battery Precinct was announced by the federal government. We'll do just that here in Queensland as well.
Do any of the rest of the audience have a No?
So if any, having done quite a bit of work recently with UK BIC, I don't know that there's enough demand in this country to support a facility of the size that they have in Coventry. That facility runs at a loss. It requires a check from the UK government every year to keep the lights, the power, and everyone employed. Now, as I understand it, it's a loan from the federal government to establish that facility, so it's an equity loan. They're expecting it paid back. So unless there's going to be a mass number of startups in the next few years that are going to be piling through a facility like that, then there's a challenge that has to be answered around how is that going to work. Yeah. So there is a tension there around, and I understand, I love cell chemistry as well, and that's where I started, but we need to ask the question, what do we really need here that's going to move the dial? And I think there's a conversation that needs to be had around the table about where do we spend our money that's going to give us the best bang for our dollar. Yeah. And I would prefer to see more investment with what exists in the country, where we have in Deakin, where we have in Queensland and things, but maybe partnerships with bigger facilities where we don't have to cover the cost of the infrastructure, we don't have to do the maintenance, we don't have to upgrade it, but we get fee for service, pile in, do our thing, back out the door. So, yeah.
That's an interesting model. Please, another.
Andrew Davies from LAS Energy. UK BIC, it's a good point you raised because we looked at that facility and certainly it's very cost prohibitive as a commercial user as well to try and run a production run through a facility of that size. So it's certainly not sure that was the right size for what...
Stay tuned.
Yeah, so you're on the right point.
So just clarify that, you thought it was good but it was not the right size, or what?
Oh, it was certainly too big to run any sort of testing program through it because it was £1 million or something to run a test run.
Yeah, there's different drivers for these things.
That's right.
So over in Europe, they had a driver there for EV, so they could go to that scale. We don't have those drivers here, and that's what I was talking about, where we need to be careful.
I suppose this is the interesting question, because what we're going to say is how do we create those drivers if we really want to have a working economy around that, or working manufacturing base within Australia? Or do we just basically follow the world's drivers?
So even the UK BIC is scaling back. So they've got this big production facility, but they've got government support from European government to actually go back down and do what we do here, the pilot scale processing, the 10-litre slurry production, small scale, because that's needed to qualify and test the cells and translate ideas, novel ideas, out of universities or companies into manufacturing. And that's what we need to do.
I just want to add one point, actually, about the investment. If you're looking at the battery value chain, and in Australia, the investment from the upstream, like from the mining, refinery, actually they're talking about the scale for billions. and then we go into the medium stream, and it's talking about a few hundred million, and going further downstream, and basically the manufacturer is also talking about the millions. Yes. So basically, if you really want to get to the scale of gigawatts hour scale, you need to have at least at the billion scale investment. Yeah. That's actually need a combined efforts from government, industry, and also maybe the research institute can support. So that certainly actually need. But if you look at the economic complexity, and it's very embarrassing for Australia, to sitting in the very low level, and we also talking about the research and development investment of the country is barely 1.7%. So the world average is about 2.2, 2.3, and the other advanced academic countries, they're talking about 4 or 5% GDP. I think there's certainly a lot of room for the improve.
I think that's what Adam was saying. He's saying that we've got all of these natural resources, and all that we do now is just ship them out. And so why can't we tag on to that a higher value, be it electrolytes, be it carbon, things like that, to try and get a higher added value, not necessarily make all the batteries, but we can certainly start with that. Jenny, I think you wanted to say something.
I'd like to make one other point about investment in future. And I know it's a buzzword, but artificial intelligence and machine learning, we're already behind in this country in terms of what it can do for understanding and designing battery materials right the way through to all the assembly, understanding the data that's coming out from batteries that are in operation. We don't in Australia have the manpower to do a fraction of what the machines can do now, and we don't have the brain power in Australia yet. So in terms of investment in future technologies, artificial intelligence has got to be another area that we're really investing in and growing, and it can really help our industry across the value chain.
Absolutely. I am aware of time. Any other questions? I mean, you've been a guru on this all morning, and now you've had all of this panel and their expertise. What's your comment? Have we got feedback on what you just heard?
I promised Lynette that I wasn't going to be controversial, but I will.
Please. So, controversy is good.
Firstly, everyone, listen to what Adam and Josh said.
Yes.
We don't need to talk about this. I'll be blunt. Crap. Yeah. Look at the Accenture report. It told you.
Yes.
It's crystal clear. That's the space that we need to be working in. And frankly, Australia is an international laughingstock.
Yes.
I mean, this is not a reflection on the Prime Minister at all. Renewable energy superpower, whatever you're smoking, it's illegal, I can tell you. We heard 0.53% of our lithium is turned into value here.
Yeah.
I mean, these poor people sitting here are rats in a cage fighting over a piece of cheese because we nickel and dime our research sector.
Yes.
They're underpaid and undervalued, and it's a failure of the universities and of industry. How many people from industry up here?
True.
Not one. Not one. And probably because you couldn't find too many. It's a failure on both sides. And
interrupt there. Because I asked people from industry.
Didn't ask me. And by the way, I'm an adjunct professor and I've co-supervised 15 PhD students. I know how hard it is. I sympathise for you. You don't get the good deal that you should be getting. But the space to be working in is this high value. The biggest value-adding step is taking the raw materials and turning them into the refined products.
Exactly.
That's the biggest return on investment. Now, stationary storage, great. Australia's big enough for that.
Yes.
Let's work on that as well. But gigafactories? No way.
I think that's probably some truth in that, definitely. And there's nothing controversial about that at all. Anybody else? Are we going to finish off or not? Please. Oh, we started something now. I'll take that one. This gentleman here.
Tesla and General Motors said they are going to buy lithium batteries in the next few years below $100 per kilowatt. I think to manufacture lithium battery is a lost cause for Australia. And I think also just now, before lunch, we saw a graph assuming that battery will be used mostly for cars only. But I see a huge demand for battery, utility scale for hydrogen production, because the electrolyzers cannot run at night. So if we if we are going to manufacture battery in Australia, might as well manufacture sodium battery because we can produce it at $10 per kilowatt, possibly. So manufacture lithium battery is a lost cause already. I mean, Korea, Japan, China, the government is giving massive subsidies to those lithium battery manufacturers. There's no way Australia can compete, so it's a lost cause. Anyway. Thank you.
I think we're all in agreement.
Pleasure.
I think we have some very clear directions to go. I think there's an amazing bunch of science. I think you're going to make a whole series of products which will tell us what are the ingredients we need to make, which we can then manufacture for the future. And I think we should leave it at that. Thank you very much to the audience. Thank you.